I'm going to describe our use of the ARM mbed technology in our undergraduate laboratories. We have two student parts kits, a starter kit for early courses and then an add-on kit used with both kits in advanced courses. We distribute over 300 parts kits per semester. The starter kit's used in the early computer organization and software engineering classes. It supports C, C++, and assembly language development. Here's a picture of the parts in the first kit. This is the mbed platform we use. It has all the standard digital I/Os with easy-to-use C++ APIs. We build projects on breadboards. It has an easy-to-use cloud compiler, runs in any web browser. Students can work anywhere with Wi-Fi on a PC or Mac. The tool also supports assembly language development. You can send data to the PC or Mac over the USB serial port. Laboratory projects typically use the mbed APIs or assembly language to add features to an existing game or other application. Here is a Pac-Man game. The color LCD comes in the kit. Here is a Nest-style thermostat. It uses an analog temperature sensor. This is a media player. It uses the SD file system to play video and audio. And the more advanced kit is used in the embedded systems class. It's a senior level class. It has supports for robotic, wireless, an RTOS, and several other common sensors and devices. Here's a picture of all the parts in the add-on kit. The parts can be assembled to build a small robot. Some of the parts in the kit: this is a 9 degree of freedom single chip IMU. This is a Wi-Fi chip, a Bluetooth chip, a MEMS microphone, a Class D audio amplifier, a dual H-bridge driver used to control the two motors on the robot, a breadboard-friendly potentiometer, a 5-volt relay that fits in a breadboard, a power MOSFET board, a standard RC servo, an IR distance sensor, a 12-key touch keypad, a small stepper motor. So we have Hello World type demos for each device, but in the design project, students combine several of them to build their project. Here's some example projects built using both kits and breadboards. This is a remote controlled robot using parts from both kits. A dual H-bridge driver controls the motors. Wireless to remote control it. This is a self-balancing robot using the two DC motors from the robot and the IMU. This is a Skittle color sorter. Uses the motors from the robot, a servo, a color sensor, and 3D printed parts. So you notice that they put the Skittle in, they go to the correct bin. This is an Internet of Things device, controls AC devices over a web page. The lights on the tennis shoes are controlled by an mbed. It has a Bluetooth interface, and using any smartphone, they can control the lighting effects on the shoes. The glove there has an IMU. It's used to remotely control the helicopter. This is a virtual reality suit. They have an IMU in each joint, and so as he moves around, the animated character has the same moves. This is an air drum. He has an IMU in each drumstick. The cloud-based development tools work well for student labs. Breadboards have enabled a wider variety of design projects. Robots and IoT devices probably need wireless, more RAM, and maybe an RTOS.